Second derivative test for maxima and minima. In the first derivative test, we discussed that when the derivative of a function changes its sign from positive to negative when passing through a point, then that point is the point of maxima. Suppose the derivative of a function at this point is a and at this point is minus b. So the graph of f dash x will be drawn like this. As we can see that the graph is going from a to minus b, this means that it is a decreasing function. So this means that its slope must be negative, which means if we find a derivative of f dash x, then its value will be negative. This means that f double dash x is less than 0 at the point of maxima. Now let's move on to the other case. In the first derivative test, we also discussed that when the derivative of a function changes its sign from negative to positive when passing through a point, then that point is the point of minima. Suppose the derivative of a function at this point is minus a and at this point is b. So the graph of f dash x will be drawn like this. As we can see that the graph is going from minus a to b, this means that it is an increasing function. So that means its slope must be positive, which means if we find a derivative of f dash x, then its value will be positive. This means that f double dash x is greater than 0 at the point of minima. Now let's move on to the third case. When the derivative of the function does not change its sign when passing through a point, then that point is known as the saddle point. Suppose the derivative of the function at this point is a and again it's a at this point, so the graph of f dash x will be drawn like this. As we can see that this graph is going from a to a, this means that it is a constant function. So that means its slope must be 0, which means if we find a derivative of f dash x, then its value will be 0. This means that f double dash x equals to 0 at the saddle point. Therefore, we can conclude that if f of x is a continuous function such that f dash x equals to 0 and f double dash a exists, then we can predict maxima or minima at x equals to a by examining the sign of f double dash a. If f double dash a is greater than 0, then x equals to a is a point of minima. If f double dash a is less than 0, then x equals to a is a point of maxima. If f double dash a equals to 0, then x equals to a is a saddle point. This whole process of determining whether a given point is a maxima, minima or a saddle point using the second derivative of the function is known as the second derivative test of maxima and minima. Let's understand this concept with the help of an example. Suppose we have a function f of x equals to 5 minus x squared. To determine the maxima and minima of this function, first find the critical values of the function. For this, find the derivative. Set the derivative equal to 0. Solve the equation for the critical values. As we can see, the critical point is x equals to 0. Now take the second derivative of the function. Since f double dash 0 equals to minus 2, which is less than 0, therefore by second derivative test, the given function has a maximum at x equals to 0. So this is how we use the second derivative test to find maxima or minima of a function.